Hey there, folks. In this video, we're going to be multiplying radical expressions together. In short, the general process we're going to be following is we're always going to start off by simplifying as much as you possibly can. So if we can break down some radicals, let's do that. That's going to shrink our numbers down and make mental math much simpler. Second, we are going to multiply these things together. When you multiply, numbers outside of the radicals can multiply to each other, inside the radicals can multiply to each other, but you cannot have a number outside of radical multiply to a number inside of the radical. And then step 3 is going to be simplify yet again. All right, so you always want to end by simplifying as much as you possibly can. If you don't simplify right off the bat, that's not the end of the world. It just means your numbers might get a little bit bigger and out of hand sooner. Okay, so let's see some examples here. First one I have just straight up multiplication to get the mechanics down. The second one we're going to have a little distribution involved. And then the third example, we're going to have to do some FOIL action. So this one is going to have quite a bit going on. So buckle up for that one. All right, here we go. For the first one, I want to simplify first. So let me take this whole piece and I'll kind of scoot that down that way. This one over here, I'll scoot that down that way. Underneath the radical of 5, I can't really break that down at all. So that's going to stay. So it'll stay as a 5. I have an x squared. Well, if we're taking a square root, that means I have one pair of x's. So this x squared can actually get pulled out on the outside. And then I have 3 y's, which is enough for one pair of y's on the outside. And I wouldn't have, or I'd have one left over. Okay, so if I were to do that, this would be 3x squared, right? Because I have x times this x here, y. So that's what this thing simplifies into. Over here, we'll do the same thing. I can't really do anything to a 15, right? That breaks down into a 5 and a 3 if I were to try to break that apart. But 5 and a 3, there's no pairs there. However, I do have a single pair of x's that I could pull out. So since there's 3 x's, right, I've got one pair and then one left over. So this would become, we already have the 2xy squared out front, but I'm going to throw another x into the mix. So x squared, y squared. And then on the inside, we have 15 and just one of those single x's. So that was step 1, right? Simplifying. Step 2 is going to be multiply. When we multiply these things, the portions in front of the radicals can multiply together. And then the portions underneath the radicals can multiply together. So let's do the portions outside. I've got 3x squared y times 2x squared y squared. So 3 times 2 is 6. X squared times x squared, I have x to the 4th. Plain old y times y squared would be y to the 3rd. And then inside the radicals, I've got 5 times 15. Let's see, 5 times 10 is 50, 5 times 5 is 25, so 75. And then I have a y, I have an x. I like to write them alphabetically, so I'll just call that xy. All right, so step 2, multiply. That's done. Now I need to see if I can simplify at the very end. Looking at this, I don't have enough pairs of x's or to make a pair of y's, so I know that I can't really do anything there. Let me break this apart and see if I can get a pair of prime factors. Oh, yeah, looks like we can break down the 75 a little bit. So a 5 will come on the outside here. And then I have a 3 left over inside with the x and the y. And we still have this 6x to the 4th, y to the 3rd hanging out there. So if I wanted to make this pretty, 5 times 6, that'd be 30. X to the 4th, y to the 3rd, rad 3xy. So again, it's a little tedious to simplify first and then multiply and then have to simplify again. But like I said, it does help kind of shrinking our numbers down. So let me get a little divvy line there. Let's see some distribution. All right. First off, a 12. That can break down into a 2 and a 6. 6 breaks down into a 2 and a 3. So I've got a pair of 2s with a 3 left over. So that'd be a 2 rad 3. But we already had the 2x chilling up front. So 2x times 2 rad 3. That's going to turn into a 4x rad 3. Let's do the same thing now with the rad 8. X to the 5th. So I've got 2 and a 4. 4 is a 2 and a 2. Got a pair of 2s with a 2 left over. Okay, so I've already got the 3 hanging out front. And then we have a pair of 2s thrown into the mix. So the 3 is already chilling out there. A 2 can get pulled out. If I have 5 x's, that's enough to make 2 pairs of x's. And then I'd have 1 x left over. So that's what that simplifies into. So let me transfer this down all pretty. Let's see, 3 times 2x squared, that'd be 6x squared. Rad 2x. And last one, 4 rad 5. I can't really do anything to. All right, there's no letters to keep track of. I can't really break down 5. 5's already prime. All right, so we've simplified. Step 1 done. Now let's multiply. As I alluded to before, we need to distribute. So let's distribute the 4x rad 3 onto the 6x squared rad 2x. So 4x times 6x squared, 4 times 6 is 24. X times x squared is x to the 3rd. So again, the outside of the radical numbers can multiply to each other. Under the radicals, I have a 3 times 2x. That would be 6x. Let's do the same thing now for the second radical. Outside numbers can multiply to each other. 4x times a negative 4 is a negative 16x. Inside numbers can multiply to each other. So when I say inside, I mean inside the radical, underneath the radical. 3 and a 5, that makes a 15. And if I can, I'm going to simplify. 6 breaks down into a 2 and a 3. There's no pairs there. I only have 1 x. That's not enough to make a pair out of, so I can't really do anything here. And 15, I can't really do anything to. So fortunately, our final answer was already simplified. Yay. Now, if on this one we did not simplify first, you'd still ultimately get to the same answer. However, you would have to do 12 times 8x to the 5th. If you did 12 times 8, you're going to result with 96x to the 5th, and that's going to be much more of a pain to factor out and simplify. So by simplifying first, we keep our numbers nice and small, which is more mental math friendly. All right, last and final one, then we're calling it a day. First thing I need to go through and simplify any radicals. Rad 5, nothing, can't do anything. 2, there's really no pairs that go into it, right? That's already prime. I don't have enough x's for a pair, don't have enough y's for a pair. 15 is a 3 and a 5, no pairs there, and I don't have enough letters, don't have enough x's. 2, I can't do anything. All right, sweet. So step 1 has already been done for us. I can't do anything there. Great. So let's go first times first. 2x times 3 is a 6x. Rad 5 times rad 15x would be a rad 75x. 2x rad 5 times a negative 4 rad 2y. 2x times a negative 4 is a negative 8x. Rad 5 times a rad 2y is rad 10y. Excuse me. Now onto this one. 3 times 3, if I multiplied this second term here with the first term here, is a 9 on the outside. 2 times 15 is 30. Xy times x would be x squared y. And last one, 3 times a negative 4 is a negative 12. And underneath the radical, 2xy times 2y is 4xy squared. Gross. Step 2 has been done. Now we need to go through and simplify if we can. All right, so 75. I feel like we've already broken apart 75, which we did. So spoiler alert, we're going to get 5 rad 3, so let's act surprised when that happens. 25 and 3, 25 is 5 and 5, got a pair of 5s, who knew? So that pair of 5s is going to come out to the outside. So I'm going to have 5 times 6x, which is 30x. We have the 3 stuck inside, this guy right here, stuck inside. And there was an x. We didn't have enough x's to make a pair to pull out. Next, rad 10y. If I broke down a 10, I'd get a 2 and a 5, no pairs. And I don't have enough y's to make any pairs, so this one I can't do. We're going to learn that it's pretty great for us if we have something that cannot be factored and simplified. Rad 30x squared y. Well, I'm already telling I've got enough for a pair of x's, so that's going to come out. Let's see if we can break down 30. 3 and 10, 10 breaks down to 2 and 5. Yeah, there's no pairs there, so I can't really do anything other than this x squared. So this would be 9. If I have 2 x's, that's enough to make one single pair, so I'll have 1x, or an x to the first power on the outside. And then the radical, we still have a 3, a 2, and a 5, which all multiplies to 30. Y. Last one, we have negative 12 rad 4 xy squared. Well, 4 breaks down into a 2 and a 2, which, I mean, we kind of know that, right? Square root of 4 is just 2. That's nothing new for us. But I'm also going to have enough y's to make a pair, so I can pull a y out, which means I'm only going to have an x left over. So this might look a little weird. So we're going to have a 2 being multiplied out and a y on the outside here. So that's going to be 12 times 2 is 24. Then we had the y that got pulled out. That's a y, not a 4 up here. And then underneath the radical, we've already taken care of the 4, so that's already good. We just handled the y squared because that was a pair of y's. So the only thing left is just a plain old x. As ugly as this is, this would be our final answer. You know the drill, folks. If at any point something did not make sense, do not hesitate to reach out.